In this problem, we are given a graph and we are asked to determine two different Hamilton or Hamiltonian circuits in the graph. Now recall, if it's a Hamilton circuit, the starting vertex and the ending vertex must be the same, yet since it's a Hamilton circuit, we must use every vertex exactly one time except for the beginning and ending vertex. Since there could be many Hamilton circuits in this graph, let's go down through the list of choices and see which of those paths or circuits are Hamilton circuits. So let's start with A. So if we look at A, it begins at vertex E. And then it goes to H, and then I, F, E again, which would be a circuit, but it's not a Hamilton circuit since not all vertices are used, and it uses that vertex more than one time. So this is not going to end up being a Hamilton circuit. We can continue, but let's see, G, D, A, B, C. The two reasons why this is not a Hamilton circuit is it's not a circuit because it begins at E and ends at C, and also it uses the vertex E twice and not at the beginning and the end. So A is not the correct answer. So we put a line through A, realizing that is not a correct answer, and erased our path for A. Now let's move on to B. B indicates to start at G, go to vertex E, then to vertex H, I, F, and then vertex C, vertex B, vertex A, vertex D, and vertex, G down at the bottom. And if you recall, we began at G, we visited every vertex exactly one time, and our ending vertex with G. So that is a Hamilton circuit. So that is one of the correct answers, is B. Now remember, with a Hamilton circuit, you do not have to use every edge on the graph. You have to use every vertex exactly one time, except the starting and end vertex. So I'm going to highlight this one to indicate that is a correct answer. And let's see if we can erase that. Erases quite nicely. And let's move on to C. C, we begin at vertex A, then we go to B, then we go to C, F, I, H, it says down here go to H to G, but you notice there is no edge from H to G. So we can't make up edges if they're not there, so C will not be a correct answer, since there is no edge from H to G. So let me take my pen and cross off C. So we crossed off A, and we crossed off C, because C is not a valid circuit. Let's go back to my highlighter and use purple this time, and let's erase C. Okay, so purple, let's start with G. So we're on to D now. G, E, D, A, B, C, F, I, H, and again it had HG in there for some reason, but there is no edge from H to G. So we do not have a valid Hamilton circuit. So we can take our pen and we can cross off D. Remember, to be a Hamilton circuit, we have to begin and end at the same vertex and use every vertex exactly one time except the one we begin and end with. Let's just take another highlighter. Let's go back and do green. Let me erase. Okay. Now for E, it says start at A, go to B, C, vertex F, I, H, E, G, D, A. You notice we began at A and we ended at A, and every single vertex was used exactly one time besides the beginning and ending vertex. So again, we'll highlight that green as in good. That is a Hamilton circuit. So the answers would be B and E are the Hamilton circuits for that graph.